I've spent 30 years watching the night sky, 30 years pointing telescopes toward distant galaxies, observing stellar remnants, tracking the elegant machinery of the cosmos. But every now and then, the sky watches back. And when that happens, everything changes. If you're here because you sense something extraordinary is unfolding, something that challenges what we thought we knew about our place in the universe, then hit that subscribe button now. Because what I'm about to share with you isn't just another story about a comet. This is about whether we're truly alone, and whether the silence we've always assumed surrounds us might actually be listening. Let's talk about 3 IATLAS. Back in July the 1st, 2025, to be precise, astronomers at the Atlas Survey Station in Chile spotted something peculiar, just a faint pinprick of light against the cosmic background. Nothing remarkable at first glance. These surveys detect thousands of objects every year: asteroids, distant galaxies, the occasional comet making its way through our solar neighborhood. But this one was different. When they calculated its velocity, they found it was moving at 137,000 miles per hour. That's extraordinary. Your typical asteroid in our solar system travels at maybe 20 to 30,000 miles per hour. This object was moving 5 times faster than anything local should move, and then came the trajectory analysis. You see, when you trace an object's path backward through time, you can determine where it came from. Most objects in our solar system follow elliptical orbits, closed loops around the sun, bound by gravity, endlessly cycling. But 3 IATLAS, its orbit isn't elliptical at all. It's hyperbolic, wide open, which means it came from somewhere else entirely, from between the stars. This is only the 3rd confirmed interstellar object we've ever detected. The first was Oumuamua in 2017, that strange elongated visitor that accelerated without any visible cause. Then came Borisov in 2019, which at least looked and behaved like a proper comet. But 3 IATLAS, it doesn't fit either category. And here's where the story begins to unsettle me. When the James Webb Space Telescope turned its instruments toward this visitor in August, the spectroscopic data revealed something unusual. The coma that's the cloud of gas and dust surrounding the nucleus was dominated by carbon dioxide. Now, comets do contain carbon dioxide, but typically water dominates. This had a carbon dioxide to water ratio that was extreme, abnormally high. Then the Swift Space Telescope detected hydroxyl emissions at approximately 3.5 astronomical units from the Sunday. That's remarkable, because water shouldn't be sublimating, transitioning from ice directly to vapor at that distance. It's too cold. Yet there it was, losing water at a rate of about 40 kilograms per second, far from where conventional comet physics says it should. And then came the polarization measurements. When light reflects off dust particles, it becomes polarized. The waves align in specific directions. Every comet we've ever studied shows what we call positive polarization at large viewing angles. It's a universal signature. But 3 IATLAS showed negative polarization, 2.77% at a phase angle of 6.4 degrees. That's never been observed before. Not once. Not in any comet throughout recorded history. The dust surrounding this object is fundamentally different from anything in our solar system. Think about that for a moment. Imagine studying water your entire life, its freezing point, its boiling point, its molecular structure, and then one day encountering a substance that looks like water, moves like water, but when you measure its properties, they're completely inverted. That's what we're dealing with here. But it gets stranger. By September, researchers had compiled over 4,000 separate observations from 227 observatories worldwide. They were tracking 3 IAT LAS with extraordinary precision, looking for any deviation from a purely gravitational path. When comets approach the Sun, they outgas, releasing jets of vapor that act like tiny rocket engines. We can measure this in every active comet we've studied. But 3 IAT LAS showed virtually no non-gravitational acceleration despite visible active outgassing. Harvard astrophysicist Avi Loeb calculated what this means. If the object is releasing material but its path remains unchanged, the nucleus must be extraordinarily massive, so massive that these powerful jets barely budge it. Their estimate? Over 33 billion tons. That's 73 trillion pounds, 1,000 times more massive than Borisov, the previous interstellar comet, and travelling faster than both Oumuamua and Borisov combined. Here's the puzzle. Based on the density of interstellar space, we should have encountered hundreds of thousands of smaller objects before finding something this massive. Loeb puts it plainly, we should have discovered 100,000 objects the size of Oumuamua before encountering 3 IAT LAS. We've only detected 2 previous interstellar visitors, so either we've been extraordinarily unlucky or something else is going on. Now, let's talk about geometry. Our solar system's planets orbit the Sun in roughly the same plane. We call it the ecliptic plane. If you could look at the solar system edge-on, you'd see all the planets moving in a thin disk. 3 IAT LAS approaches on a trajectory inclined just 5 degrees relative to that plane. 5 degrees. The probability of an interstellar object randomly arriving with such precise alignment, 1 in 500. That's 0.2%. Not impossible, certainly, but uncommon. But it's not just the alignment, it's the timing. On October the 3rd, 2025, 3 IAT LAS passed within 18 million miles of Mars, travelling at 193,000 miles per hour. Before that moment, we had 7 spacecraft in position around Mars, NASA's Mars Reconnaissance Orbiter, with its high-rise camera capable of 30-kilometre pixel resolution.
The European Space Agency's Mars Express and Trace Gas Orbiter, NASA's MAVEN atmospheric probe, China's Tianwen-1 orbiter, and the UAE's HOPE mission. The geometric setup was perfect. We could have obtained unprecedented images, surface features, structural details, the kind of data that settles questions definitively. And then, 48 hours before the flyby, something curious happened. NASA's public data streams went quiet. Not completely dark, that would be too obvious, but muted, delayed. The usual real-time telemetry feeds that researchers around the world monitor, they slowed to a trickle. Updates that normally post within hours took days. Image releases that typically happen immediately were postponed indefinitely. The official explanation? Government funding issues, bureaucratic complications. Perfectly reasonable, perfectly mundane explanations, except the timing. Precisely when the most important observational window in interstellar astronomy was opening, the information pipeline constricted. Not before, not after, exactly when it mattered most. And here's what troubles me. Internal communications, the kind that leak through academic channels, through conference whispers, through late-night emails between colleagues, suggested that certain instrument readings were being flagged. The word that kept appearing was anomalous,
anomalous readings, flagged for review, removed from preliminary databases pending verification. Now, I want to be clear, this happens in science. Instruments malfunction, cosmic rays strike detectors and create false signals, data gets contaminated, cautious. Scientists don't release questionable results immediately. That's proper methodology. That's how good science works. But when questioned readings coincide exactly with humanity's best chance to observe an interstellar visitor at close range, the skeptical part of my mind begins asking uncomfortable questions. There's something else. Something that hasn't made it into official press releases, but circulates through certain research networks. A faint radio emission, brief, structured, detected by deep space monitoring arrays minutes after the Mars Reconnaissance Orbiter completed its closest approach flyby. Now, interstellar objects can emit radio waves naturally. Plasma interactions, charged particles interacting with the solar wind, perfectly mundane physics. But the pattern of this emission, the frequency distribution, the temporal structure, resemble patterns we typically associate with modulated signals rather than random noise. I'm not saying it was a transmission. I'm saying it matched transmission-like characteristics. And according to sources who've seen the preliminary analysis, sources who requested their names not be used, the signal was quietly placed under review embargo, not published, not discussed in open forums, classified under protocols typically reserved for sensitive observations. Again, I want to emphasize there are legitimate reasons for this. If you're uncertain about data quality, you don't announce potential discoveries prematurely. The embarrassment of retracting a false claim about extraterrestrial signals would be considerable. Careers have ended over less, but the pattern emerging troubles me. Anomalous instrument readings, flagged and removed, radio emission with structured characteristics, embargoed pending review. Public data streams restricted precisely during the most critical observation window. Individually, each has a reasonable explanation. Together, they form something that looks suspiciously like coordinated informational caution, or, if I'm being less charitable, coordinated silence. Let me tell you about something we observed that violates basic comet physics. For 2 months, from July through most of August, 3 IATLAS displayed what astronomers call an anti-tail. That's a structure extending toward the sun rather than away from it. Now, comets occasionally show optical illusions that look like anti-tails due to geometric perspective. You're seeing the curved dust trail from a particular angle, and it appears to point the wrong direction. We understand that. It's well documented. But when researchers analysed the Hubble images carefully, accounting for viewing geometry and perspective effects, they concluded this wasn't an optical illusion. The structure was real. Material was genuinely extending sunward. That shouldn't happen. Solar radiation pressure, the solar wind, everything pushes material away from the sun always. It's like gravity. It doesn't reverse direction. Yet for 2 months, 3 IATLAS appeared to be ejecting material in the opposite direction from where physics says it should go. Several theoretical papers have been hastily written attempting to explain this. Perhaps it's some exotic electromagnetic interaction we don't fully understand. Perhaps the rotation of the nucleus creates preferential jetting patterns that happen to aim sunward. Perhaps there's internal heat driving sublimation on the wrong side. Perhaps. But perhaps is what scientists say when we don't actually know. And then, on August 27th, imaging from the Gemini South telescope revealed that a normal tail had begun forming material streaming away from the sun as expected. The anti-tail gradually faded. It's as if the object corrected itself, transitioned from anomalous behaviour to normal behaviour, right, as we were watching most closely. As I record this, it's late October. 3 IATLAS reached perihelion, its closest approach to the Sun, on October the 30th, at a distance of about 1.4 astronomical units. That's roughly 130 million miles, just inside Mars's orbit. And during perihelion, the object passed behind the Sun from Earth's perspective, solar conjunction, which means ground-based telescopes couldn't observe it. The Sun's overwhelming brightness blocked our view entirely. Convenient timing, some might say, suspiciously convenient. When 3 IATLAS emerges from behind the Sun in December, we'll have another observational window. It will pass 170 million miles from Earth on December 19th, far enough to pose no danger, close enough for our best instruments to study it again. Perhaps then we'll get the images that were supposedly captured in October but not yet released. Perhaps the embargoed data will be published. Perhaps the anomalous instrument readings will be explained. Perhaps. But I want you to notice something. In the history of space exploration, when we discover something genuinely exciting, a new planet, a surprising asteroid, an unusual stellar phenomenon, the response is immediate enthusiasm. Scientists compete to publish first. Press releases flow. Social media lights up with preliminary images. This time, measured caution, careful silence, institutional reluctance to commit to interpretations. That tells you something, doesn't it? Either the data is confusing enough that nobody wants to be wrong, or it's clear enough that everybody's frightened of being right. Let me step back and talk about what this means. For the entirety of human existence, we've assumed we were alone. We've speculated about life elsewhere, but operated under the assumption that consciousness and technology are rare accidents confined to one small planet. 3 IATLAS challenges that assumption. If it's natural, and it probably is, then we're learning that interstellar comets can be far more massive and chemically diverse than we imagined. That teaches us about planet formation in other star systems, about the composition of interstellar space. But if it's not natural, then everything changes. An artificial probe passing through our solar system means we're not alone. It means somewhere out there, someone else looked up and didn't just wonder they built something. They sent it into the darkness. They reached across the vast emptiness between stars. And if they detected our planet using transit methods, they might have designed a trajectory that stays close to the ecliptic plane, arriving with timing optimized for planetary encounters. Something that looks almost like a comet, just different enough that careful observers would eventually notice. A Trojan horse drifting through our cosmic neighborhood. I don't want to feed paranoia or suggest conspiracy. Most likely 3 IATLAS is exactly what it appears to be. A very unusual chunk of ice and rock ejected from some distant planetary system billions of years ago. Most likely, but we owe it to ourselves to look carefully, to not dismiss anomalies simply because they make us uncomfortable, to follow the evidence wherever it leads. So what do we do with this? First, we keep watching. The European Space Agency's JUICE spacecraft will observe 3 IATLAS in November as it continues outward. Additional data will arrive. We'll refine our size estimates, our composition models, our trajectory calculations. Second, we demand transparency. If there are anomalous readings, publish them. If there are unexplained radio emissions, release the data. Science works through open scrutiny, through peer review, through thousands of independent researchers examining the same evidence and reaching their own conclusions. Secrecy helps no one except those frightened of being wrong. Third, we prepare ourselves mentally for either outcome. If 3IATLAS proves natural, we celebrate the expansion of our knowledge. We write new papers about interstellar chemistry and orbital dynamics. We adjust our models and move forward. But if it proves otherwise, if even one piece of compelling evidence emerges suggesting artificial origins, then we face a profound reckoning. Not with the object itself, remember. It will pass 170 million miles from Earth, far too distant to pose any physical threat, but with our understanding of our place in the cosmos. Are we the young civilization, the first to develop technology in our corner of the galaxy? Or are we the ones being observed, studied, catalogued by intelligences far older than our species, older perhaps than our entire solar system? 3IATLAS may be between 7 and 14 billion years old based on its galactic trajectory, older than Earth, older than our Sunday. A wanderer that's been drifting through the galaxy since before our world even existed. What stories could such an object tell if it could speak? I started this by saying that every now and then the sky watches back. 3IATLAS, whether it's a comet or something more, has reminded us that the universe is not empty, not silent, not indifferent. It's full of mysteries that challenge our assumptions. It's full of phenomena that don't fit neatly into our categories, and that's beautiful. That's what science is supposed to be. Not the comfortable confirmation of what we already believe, but the uncomfortable confrontation with what we don't yet understand. So here's what I ask of you. Subscribe to this channel if you haven't already, because in the coming weeks and months, as more data emerges, as 3IATLAS continues its journey outward past Jupiter and eventually back into the darkness between stars, we'll be tracking it together. We'll look at the evidence as it arrives. We'll ask the hard questions. We'll follow the story wherever it leads. Hit the notification bell so you don't miss updates. Share this with anyone who believes space is boring, because this will change how they see the universe. And most importantly, stay curious, stay skeptical, demand evidence, but remain open to surprise. Because whether 3IATLAS turns out to be the most unusual comet we've ever studied, or the first confirmed artifact from another civilization, it's already taught us something profound. The cosmos is stranger, more complex, and infinitely more interesting than we ever imagined. The sky is watching. Let's watch back.